Alright, welcome back, class. Today is more easy inequality stuff. And I've gone back to the thick markers because I think the skinny ones were difficult to see. So I guess over spring break, I will be buying markers, which is what everybody wants to do on spring break. Living the life buying markers. Alright, so remember, if you have these symbols, face, open dot. If you have the or equal to symbol, close dot. So if I say x is less than 2, the lazy man's graph, you graph 2, open dot, because it says less than, not or equal to. And you either kind of embolden this area or draw an arrow pointing that way. I've seen it both ways. I'm okay with either one. That's what it is. Alright, you will notice in this section there's a couple of things. You might see something where you have two inequalities with the word and. If you see the word and, it's conjunction. So and is like, can you go to the store and buy milk and Oreos? You said and, conjunction, you want both. The other option is or. Or is called a disjunction. Junction. Geez, English language is not my forte. So, you can go to the store and here's some money. You can buy a bag of chips or cookies. Or, you get one or the other. She's dying. I'm okay, it's all good. So, that's a disjunction. If you want that one. So, if I said t is less than 5 and t is greater than or equal to 5, right? If there's not the word and, bumping into things. If it's not the word and, you could have less than 5 and then 5 or bigger. So that would be legit everything. However, and there's not a number that is less than 5 and also greater than or equal to 5. So like 5, that's not less than 5. It is greater than or equal to 5, but it doesn't meet that requirement. 4 is less than 5, but it's not greater than or equal to 5. So there is no answer to this one. Okay, it's not that any conjunction, there's no answer. There will be conjunction where there's answers. Like, so for example, greater than 3, but less than 5. 4. Okay, so there are conjunctions that work. This one just doesn't work. Disjunction, right? T is less than 5 or t is greater than or equal to 5, right? Or you're gonna have less than 5, so like 4, 3, 2, 1, negative 1, blah, blah, blah. Or 5, 6, 7, 8, 9, anything bigger than 5 or equal to 5. So your graph would, you don't really have a dot because 1 is less than, 1 is or equal to, so you just kind of leave it. And you'd kind of just color everything. Because you could have anything in there, because you have one or the other. And any number will meet one of those two requirements. Alright. Now for the main part, what you'll see more commonly is solving. Let's say x minus 2. And then graph. Okay. With these, you see this is in the middle. I need to add 2 to both sides. I'm doing the opposite of whatever that says. Right now it says subtract 2 or minus 2. So I'm going to add it, but to both sides. So negative 3 plus 2, negative 1, x, no longer in there. And that symbol is not there. And then 4 plus 2 is 6. Alright, cool. We have x all by itself. No negative, no constant in front. Constant? Coefficient. Coefficient. And then you graph. So, lazy graph, right? You know it's going to be between these two things. Solid. Because that. Open. And then badoom. So 6 is not okay, because it's not or equal to. -1 is okay, and then anything in between, perfectly okay. That's how we do it. This blue marker is decent. Not so much for the other ones, though. Alright. We gonna be alright. An example of a disjunction. Another one. More traditional one. 2w minus 1 less than 3, or 3w greater than or equal to w plus 10. Alright? I need to add 1. So I'll have 2w is less than 4, which means w is less than 2. Or I need to subtract w, so I will have 2w greater than or equal to 10 divided by 2, divided by a positive number, so I don't need to flip the sign. 5. Okay. So we know I'm going to have 5. If you want to label 4, 3, 2, you can. If you just want to put 2 and 5, I'm okay with that. Some people might think you're lazy and say don't do it that way, but I don't care if you just put the 2 numbers there. Or this way. So, one or the other. If I put the word and, there's no way that you would have a number that meets both those requirements because they're going in opposite directions. However, or I could either have some numbers over here, or I could have numbers over there. That's how it goes. So the last example I want to do, and I really tried hard to find a difficult one, so this is the best I could do, because they're not difficult. This number 38 in your book, if you have our book. 1 minus 4m less than or equal to 3 minus 5m less than or equal to m minus 3. Alright. You want the variables in the middle. So, I am in anything else on the outsides. So, I'm going to subtract 3. So 1 minus 3 will give me minus 2. I am going to move this 4m inside and this m inside. So I'm going to have minus 5m plus 4m. So that gives me minus m. And I subtract another m. So I'll have minus 2m. Now I moved that 3 there. Remember, you have to also move it over here. So minus 3 minus that 3. Minus 6. And now you have to divide by minus 2. Now we're dividing by a negative. That means I'm going to have to flip the sign. So 1 less than or equal to m. Wow, I said flip the sign and then I didn't flip the sign. Good job. Flip the sign. Flip that sign. Right? So m is less than or equal to 1, greater than or equal to 3. So, we're going to have 1, 3. Less than or equal to 1. Greater than or equal to 3. And there we have it. Obviously, you can't have one that is both less than that and greater than that. You can have one or the other, right? So, that's the lesson. Catch y'all after spring break.